In this presentation, we are going to learn about the plotting of sites. It is also known as graphical combination of sites and is also known by the name of staggered observations and simultaneous observations. All these names meaning the same thing. Let us now try to understand what this actually is. In celestial navigation, we have worked upon celestial sites, celestial observations, using different bodies, sun, stars, planets, and moon. We have used different methods depending upon the situation, like meridian passage, latitude by meridian altitude, long by Cron, intercept, X meridian, and Polaris. Now, all these methods have given us position lines. If we take one celestial observation or if we take one celestial site, we can obtain one position line for that time. Now, the ultimate aim of the navigator is to fix the vessel's position. So, the ultimate result which we want from this exercise of site taking or observations is that we should be able to fix up the position of the ship. If we have a position line, it just signifies that the vessel's position lies somewhere on that position line. It does not tell us where is the vessel right now. It could be the position line, could be running in dangerous waters, it could be running in safe waters also. So just knowing a single position line does not help the navigator much. What we are ultimately interested in is getting the position of the vessel or getting a fix. Now for getting a fix, we need to have minimum 2 position lines. If we have 2 such position lines, then we know that wherever these position lines intersect will be our position. So this is our ultimate objective for site taking, that we should be able to obtain at least 2 PLs, and combining those 2 PLs, we should be able to get the position of the ship. Now for obtaining 2 position lines, we need to work at least 2 astronomical sites. One observation gives us 1 PL. The second observation gives us the second position line. And once we have these 2 PLs, we can plot them on the chart or on our plot. And wherever these 2 lines intersect will be the position of the ship. Now, it is possible that 2 celestial bodies may be available to us at a particular time. So in that case, the site can be taken for both these bodies at the same time. And if 2 sites are taken at the same time, it is known as a simultaneous observation. Now, in some other situations, it is possible that there may be only one celestial body available to us at a particular time. Let us say, for example, you want to take a site during daytime. The only body which may be available at that time could be the sun. Now, with no other celestial body available, it is not possible to take a simultaneous site. You cannot take 2 sites at a single time. So what can be done in those scenarios is, you can take one single site of the body and then wait for some time, let the sun move a little bit in the sky to another location, and after some time you use the same body to take the site again. Now, after some time when you take the site again, you get a different position line. So now in this case, we have 2 position lines for different times. These can also be combined and can be used to get the fix of the ship. This type of observation is known as a staggered observation. If sites are taken at different times, then they have to be transferred to a single time. While transferring, we have to allow for the vessel's speed and course. And if there is any external factor like wind or current, they also have to be taken into account, and the position line transferred. Now, this kind of observation is known as a staggered observation. Usually on board a ship, when we take sights and we plot them, we are able to plot them on the chart. We have the chart of that particular area available to us. We can plot the position lines on the chart, and once they are there, whichever position they intersect, its latitude and longitude can be read off from the chart, and we have the vessel's position known to us. But in our paper, the plotting questions, staggered or simultaneous plot or graphical combination of sites question, may come in the practical navigation part. It may not come under the chart work part. So usually it appears as question number 5 or 6 of our paper, and it does not relate to the chart which is given to us. Means you will not be able to plot these sites, plot these position lines on the chart. So how do we get our position now? We have to construct a small part of the Mercator chart on our answer sheet. It can be done on a plain paper on our answer sheet, or sometimes they provide us with a graph paper. It can be done on the graph paper. The graph paper gives us a little bit of advantage. It has parallel lines and perpendicular lines, which we can use to draw our latitudes and longitudes. So otherwise, the procedure can be done on plain paper as well as on graph paper. Now, this procedure of constructing a small part of the Mercator chart on our answer sheet or on the graph and plotting 2 or more position lines to get the vessel's position is what we know as plotting of sites. So this is our ultimate aim now for plotting of sites. Now, when we plot the sites, we are provided with information which we obtain from a observation. We have seen different observations: Marpas, Long Bicron, Intercept, X Meridian, and Polaris. Now, whatever information we obtain as answer from these sites by working out these sites, that is basically a reference position from where the PL passes and the direction of the PL. These are the two information which we get from working out a site. This is provided to us in the plotting questions. So we have the site worked out and its information given to us, and we need to plot it on our answer sheet or the graph paper and find out the fix of the ship. Now, before we go into the actual procedure of plotting, let us refresh some features of Mercator charts so that we are clear about how to make a small portion of this chart on our answer sheet. Now, on a Mercator chart, all the meridians are parallel, and 1 nautical mile is equal to 1 minute of latitude. The distances are measured in nautical miles, or in other words, you can see that the scale of distance is same as the scale of latitude. The north-south distance measured on a Mercator chart in nautical miles is equal to the minutes of DLAT between the two places. The east-west distance between two places measured along the latitude scale gives you the departure between them in nautical miles. If you measure the east-west distance between two places along the longitude scale, it will give you the delong. But if you measure the east-west distance between two places along the latitude scale, it will give you the departure between them in nautical miles. So these were some features of the Mercator chart, which will help us in constructing a small part of it on our answer sheet. Now, as we have seen that on a Mercator chart, the east-west distance is the departure between two places. Now, when we make a small part of the Mercator chart on our answer sheet, you see on an actual Mercator chart, there are two different scales. We have the latitude scale and we have the longitude scale. Both of them are different from each other. That means 1 minute of latitude will be different from 1 minute of longitude. Now, if we are making a small part of the Mercator chart on our answer sheet, it will be very complicated and time-taking to make a chart having two different scales. So in our chart, in our plot, we do not use two scales, we only use one scale, and that scale is the latitude scale. Now, if we have only one scale on our plot, then you have to measure all the distances, whether they are in the north-south orientation or the east-west orientation on the latitude scale itself. The north-south distance measured along the latitude scale is the D-lat, but the east-west distance measured along the latitude scale is the departure. So we need to make sure that whenever we have to show a east-west distance on our plot, we have to show that distance as departure, not as D-long, because in our plotting, we do not use the longitude scale at all. So for putting any information or position on our plot, we will use the east-west distance as departure. Now, how to get the departure? Departure is obtained from the parallel sailing formula, which is departure is equal to D long into cos of M lat. M lat is the mean latitude. So whenever you want to put or feed or show the east-west distance on our plot, we will calculate the departure and then use it to show that particular distance on our plot. Likewise, when we are reading off any distance, east-west distance from our plot, we will always get the departure and we will have to convert it to D long using the same formula. Any east-west distance entered in the plot should be the departure, and any east-west distance picked up from the plot should be the departure. It should be converted to D long for our use. Now going a little further in plotting, the plotting can be done on plain paper or if possible graph paper. Whatever plot you do, it should be based on a certain scale. To give you an example, the scale could be 1 centimeter is equal to 1 nautical mile, or if required, it could be 1 centimeter is equal to 2 nautical miles. Whatever scale you select, it should be clearly mentioned in the plot. Without the scale, the plot is meaningless, and it is a very important items to be shown in the plot. Most convenient scales to use are 1 centimeter is equal to 1 mile, or if the diagram is not fitting on our answer sheet, the plot is big, then it can be made smaller by taking a scale 1 centimeter is equal to 2 nautical miles. Most of the questions you will be able to solve using these two scales. Now, even if you have to use a bigger scale for some question, avoid putting any fractions in the scale. Avoid taking 1 centimeter is equal to 1.5 mile or so. So fractions in scale will lead to errors. It will become difficult and time taking to convert the values, plot values to actual values. So fractions should be avoided. Now in staggered plotting questions, we need to transfer a position line. Now the position line can be transferred using two different methods. Either the PL can be transferred by applying the course and the distance steamed by the vessel to any point on the position line. The first method is you can straight away apply the course and distance on the position line, any point on the PL. You reach to a new point, and you draw a line parallel to the initial PL and the PL is transferred. Now the second method is using calculation. So in calculation, we pick up any point on the initial PL, apply plane and parallel sailing to it, and find out the position arrived after a certain course and distance has been applied to it. So this is the calculation method. We can calculate the new point or the new reference position from where the transferred PL will be passing. Now, which of these two methods should be used in a particular question? If the distances involved are less than 10 miles, you can directly apply the course and distance geometrically using the plotting tools. But if the distance exceeds 10 miles, then you should prefer using the calculation method. The reason for this being that if the distance is more than 10 miles, to show it on your answer sheet, you will have to select a large ratioed scale, maybe 1:5 or 1:10 or so. Now, as the scale becomes bigger and bigger, the errors in the plot get enhanced. If you have a scale of 1:10, then 1 centimeter is getting converted into 10 nautical mile. That means 1 millimeter on your plot is representing 1 nautical mile. Now 1 millimeter error on the plot is very much possible. The thickness of the pencil or the accuracy of your compass or divider can easily take you 1 or 2 millimeters up and down. And in that case, it will give you excessive error in your answers. So in case you have a distance more than 10 nautical miles, then the PL should be transferred by calculation, and you should avoid doing it by plotting. So we will see that in the examples going ahead.
First, we are going to see the simultaneous observations.
Now, I'm sure all of us are conversant with chart work, wherein we plot position lines and position circles to obtain the vessel's fix. It's exactly the same way as in chart work. Only difference being in chart work, we have the latitude and longitude scale printed on the chart. We have the compass roses to give us the directions, and hence we have everything available there, and we just measure the parameters on the respective scales and we do our plotting. In these questions, when we are talking of graphical representation without chart, then obviously we'll have to either use a graph paper or we'll have to do on a plain sheet taking a suitable scale. So let's run through the steps involved in solving these questions. First, we'll have to analyze the information that is provided to us to figure out adequate information so that we can get to know whether it is giving us 2 position lines, or is it going to give us 2 position circles, or else maybe 1 position line and 1 position circle. Needless to say, as the title of the video suggests, both the observations have to be for the same time, that is simultaneous observations. From the information that we obtain, we identify for position line, what is it significant for position lines is, we'll have to identify a position through which to draw the position line, irrespective of whether it's a terrestrial PL or a celestial PL. We'll have to identify a position through which to draw the PL and the direction of the PL. For position circles, we'll have to make effort to identify the center of the position circle and the radius of the position circle. Now, to be able to mark parallels of latitudes, meridians, and mark of positions and distances, we first draw one of the parallels of latitude and one of the meridians that we know in the question. And these ones drawn first act as reference for marking the remaining parallels of latitude and remaining meridians. Plot other parallels of latitude and distances on the plot. We choose an appropriate scale. Obviously, we should be choosing the largest possible scale in a given scenario. We know that the latitude scale or scale of latitude and the scale of distance are same. Why? Because 1 minute of latitude represents 1 nautical mile. What other meridians with respect to the reference meridian just discussed above? We need to find out what shall be the east-west spacing between the two meridians. Now, this east-west spacing between the two meridians shall depend between the d long between the two as well as the latitude. Why? Because we know that meridians have maximum separation between them at the equator and they all converge at the poles. So the east-west distance between them we all know is called as departure. So when we plot the meridians, we'll use the scale that we have chosen and we'll separate the meridians by a distance equal to the departure in the latitude for which the plotting is being carried out. Departure is obtained with reference meridian and the meridian to be plotted from their d long and latitude. And which formula do we use to get the departure? It's the parallel sailing formula, which is departure upon d long is equal to cosine of latitude. Now, once all the parallels of latitude that are required are marked on the plot and also the meridians, then we can use them to identify on the plot the position through which to draw the position line and the center of the position circle. Now, once the positions through which the PLs have to be drawn or the center of the position circles have been identified, PLs and PCs can be plotted. As they shall be simultaneous observations, so the intersection shall give us the fix. Now, using the scale of the plot, the delat of the fixed position can, from any of the parallels that is plotted on in our plot can be measured, and that delat can be applied to the latitude of the parallel from where it is measured, and that shall give us the latitude of the fix. Likewise, east-west distance of the fix can be measured from any of the meridians which is plotted and identifiable, and using the same scale as the scale of distance, and this shall be the departure between the meridian from where it is measured to the meridian of the fix. This departure can be converted into d long using the parallel sailing formula, and once the d long is obtained, the d long can be applied to the longitude of the meridian from where the departure was measured, and that shall give us the longitude of the fix. So this way, the fix having been identified on the plot, its coordinates can be obtained in latitude and longitude. Let's apply our learnings to an example.
They have given us a DR position 50-10 south, 140-40 east. The first observation they have given us for star X, and this is a long bichrome PL. Observed longitude is given to us. Azimuth is also given to us. So can we plot the long bichrome PL in this case?
Yes, sir.
Yes, sir.
Very good. Now at the same time, star Y meridian altitude gave an observed lat of 50 degree 14 minutes south. So this is a Marpas observation and the observed latitude is given to us. So can we plot the PL in second case also?
Yes, sir. East-west.
Very good. So let us see now. We have to find the vessel's position and we have the graph here. Let's see now how this is plotted and done.
140 degrees 40 minutes east. Star X observation gave an observed long 140 degrees 36 minutes east. Azimuth 075 degrees true. At the same time, star Y meridian altitude gave an observed latitude 50 degrees 14 minutes south. Find the vessel's position. Now, before we proceed any further, it's important to identify the methods deployed for solving the site of star X and star Y. I'm sure we can all figure out that star X has been solved using long by cron. And in such case, the PL shall be drawn through dr lat and observed long. Direction of the PL perpendicular to azimuth. As far as star Y is concerned, it's a meridian altitude observation. So the PL shall be drawn through observed lat and dr long, perpendicular to azimuth, but in this case of meridian altitude, the PL shall be specifically east-west, and hence it will coincide with the parallel of latitude of the observed lat. Now, having identified the processes deployed for solving the sites, we proceed ahead with the plotting. We have the dr lat coming up on the screen. We have the observed lat now the d lat from dr lat to observed lat is 4 minutes south. This information shall be used to plot these two parallels with respect to one another. Direction of PL of X, as already said, it will be perpendicular to 075 degrees to the azimuth, so shall be 165 degrees to 345 degrees. Direction of PL of Y shall be east-west, that is 090 degrees to 270 degrees true, being a meridian altitude observation and solved by latitude by meridian altitude. Now we come on this side. We have this dr latitude, parallel coming out here. Then we decide on the scale that we would like to use. So we'll use, as far as graph in the background is concerned, one big box as 1 centimeter. If without graph, we can take 1 centimeter as 1 minute.
So we have started the plotting now, beta, and we have plotted the dr latitude. It can be plotted anywhere. So we have picked up this particular line and considered it as our dr latitude 50 degree 10 minutes south. Now we have taken a scale also. 1 centimeter is equal to 1 mile. One box in this graph represents 1 centimeter. So easy to refer. It is equal to 1 nautical mile. Once we have the dr latitude, we can now plot the observed latitude also. Observed latitude is 50 degree 14 minutes south. So if we come 4 minutes south of this, that is the location where the observed latitude will be. So let us plot the observed lat now.
So the observed lat has to be 4 minutes south of the dr. So we go 4 minutes south, d lat 4 minutes south, and we draw the observed parallel of latitude out here. Now, in this case, the latitude that the meridian that we shall need would be the observed long. So we draw the observed long. It's drawn out here. Now we all know that for star X, the PL shall be drawn through dr lat and observed long, that is this point.
Now beta, any vertical line can be considered as your observed longitude. So wherever you have space, as per your space, you can use any vertical line as your observed long. We have picked up this particular line and named it as our observed longitude of 140 degree 36 minute east. So we have the dr lat now, we have the observed longitude now. Now we can draw the position line. Long by cron PL can be drawn.
And direction, as already calculated, as 165 to 345. We have this PL for star X coming up here, passing through this point. PL for star Y is going to coincide with the observed parallel of latitude.
Up to here, beta, any doubt in the mind?
No, sir.
Okay, great. So let's plot the second PL now.
So here is the PL for star Y. which you can say should have been drawn through observed lat and dr long, but since it's east-west, so it doesn't matter whether dr long is marked or not. Now the two PLs being for the same time, they intersect here. So this becomes the fix of the vessel. And what do we see? The latitude of the fix is same as the observed lat. And this distance is the departure of the fix from the observed long. So we see that the departure is 1.1 minutes east from the observed long. So we come this side for calculations now. Fixed lat is same as observed lat, 50 degrees, 14 minutes south. Departure, read off from the plot using the same scale out here. From observed long to fixed is 1.1 minutes east. We convert this departure into D long by using the cosine parallel sailing formula for latitude 50 degrees 14 minutes, and we get the D long as 1.7 minutes east. This D long we apply to the observed longitude, and that was 140 degrees 36 minutes east. When we apply a D long of 1.7 minutes east to it, our fixed longitude becomes 140 degrees 37.7 minutes east. So the coordinates of our fix obtained through plotting would be then 50 degrees 14 minutes south, 140 degrees 37.7 minutes east, and it's here that we have the fix of the vessel.
So this is the question completed, beta.